Okay, ladies and gentlemen, this is the second of 4 videos for Chapter 0, Section 3 of your McGraw-Hill Algebra 2 textbook. It is going to cover how to factor a binomial that fits the pattern of a difference of two squares. Now, when I say two squares, I'm talking about a difference of two perfect squares. So if you are asked to factor a binomial, you might have to recognize that that fits a difference of two perfect squares. In other words, it might take the format a squared minus b squared. So the first term is a perfect square, the second term is a perfect square, and it is a difference. There is subtraction in the middle. In that case, the binomial will factor into the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So a plus b, a minus b. Now, this brings us to a portion of your course that is less than popular every year, but I don't care because it's extremely valuable. And that is information that you are expected by me to memorize. You are expected by me to memorize the first 25 perfect squares. You will have a memorization quiz on this information in about 2 weeks. So, remember what squared means. It means times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, etc. You are expected to know all of these facts off the top of your head. And in theory, you should have at least up to 12 squared memorized from grade school. So that's not really asking that much of you. Notice that I am not having to hesitate at all as I write these values down because I have them memorized. The reason you need to have them memorized is when you see these blue numbers in a problem, you have to be able to recognize that these are the numbers that are the perfect squares, because that means if you were to take the square root of one of these blue numbers, it would have an integer perfect square root. So you are expected to memorize all 25 of those facts from 1 squared to 25 squared. You'll be having a memorization quiz on them in about 2 weeks. They will be extremely mixed up. They will not be in order. You will be expected to spit them back at me, and it is a timed quiz. So, anyway, again, those blue numbers are what's important. You have to be able to recognize those blue numbers as being the perfect squares. Now, when you factor a difference of two squares, this is still a two-step process because step 1 is still you must factor out the GCF first if it has one, if one exists. Then you will factor out the difference of two perfect squares. What does that mean? That means a squared minus b squared will factor into a plus b, a minus b. So let's do some examples. First example here, 4x squared minus 16 has a GCF of 4. So we would start by factoring that out. Again, when we factor that out, what we're doing is dividing the original problem by the GCF. It has a GCF of 4. So that is x squared minus 4. Now, anytime you have a variable to an even power, that is a perfect square. Other than that, you need to look at the coefficients. In this case, your coefficients are 1 and 4. Those are both perfect squares. There's subtraction in between. That makes this set of parentheses a difference of two squares. So, you ask yourself, what is the square root of 1x squared? That would be 1x plus or minus the square root of 4, which is 2. Again, this should be a review, so we shouldn't really need to spend a ton of time explaining the process. On the second one, we have a GCF of 2x. So we would factor out the 2x, which would cause the other two terms to get divided by 2x, which would leave 4x squared minus 1. That is a difference of two perfect squares. The square root of 4x squared is 2x. So the first term in each of my new sets of parentheses is the square root of 4x squared, which is 2x, plus or minus the square root of 1, which is 1. We're going to go through some more examples on the next page, but this is the shortest video. So after we go through these 4 examples, we'll end the second video and move to what is probably the longest video, which is trinomial factoring. Here are 4 more examples of difference of two perfect squares. On the first one, we don't have a GCF, so there's no GCF to worry about, so we skip that step. And then we go, okay, well, square root of x squared is x plus or minus 9. Now notice how we're done. It's pretty simple. On letter B, there's also no GCF. So we jump straight in and we say to ourselves, okay, the square root of 16x to the 4th would be 4x squared because we divide the exponent in half. Plus or minus the square root of 81, which is 9. Well, we're not done yet, because the second set of parentheses is still a difference of two perfect squares, so it will factor again. The square root of 4x squared is 2x. The square root of 9 is 3. Now you're saying to yourself, well, Mr. Wills, how come you didn't factor the first set of parentheses? Well, that is not a difference. Difference means subtraction. It has to have subtraction in the middle in order for it to fit this pattern. So this binomial is prime, cannot be factored again, but this is still a difference of two perfect squares, so it can be factored again. Remember that the directions are going to say factor completely, and if you don't factor completely, you will not get the problem correct. Letter C, by the way, if you think you know what you're doing, you should pause the video and try to factor the last two. Remember GCF first, then look for the pattern. Okay, letter C has a GCF of 3x. So if we factor out 3x, that means we're dividing by 3x, which would leave us with 4x to the 4th minus 9y to the 8th. That is a difference of two perfect squares. The square root of 4x to the 4th is 2x squared. And the square root of 9y to the 4th, or 8th, is 3y to the 4th. Notice that neither one of those fits the pattern for difference of two perfect squares, so we are done. The last one does not have a GCF. Here we had a GCF of 3x. So we factored that out. So we go straight into the difference of two perfect squares. The square root of 64x squared is 8x. And 625 is 25 squared. This is not a difference of two perfect squares because 8x is not a perfect square. So we are done at that point. That is how we factor difference of two perfect squares. That's the end of video 2 of 4. Our next video will cover trinomial factoring.